Hey guys, my name is Casey with the Montreal Student Network, and today we're going to be talking about alkanes. Alkanes are one of the first concepts you'll be introduced to in organic chemistry, and it basically involves the simplest form of hydrocarbons that you'll see. Now, a hydrocarbon is a compound that consists solely of carbon and hydrogen. So it's basically just going to have C's and H's when you look at the formula. So the term alkane means that it's only going to have single bonds. So we're going to write that down just to take notes. And as always, I'm trying to improve my writing on this thing. It will get better towards the end of the series. Single bonds only. Now we're going to get into naming them in the next video, but for this video we're just going to look at the three simplest forms of alkanes. They're only going to have single bonds. So when you have double bonds and triple bonds, that becomes a different topic, which I will cover in the coming weeks. So the ones we're going to be looking at today are CH4, which is methane. The methane's a little different. It doesn't have a bond line because it only has one carbon. But if we're going to draw it out to just look at the structure to verify that it is a hydrocarbon, we can do that just by doing this right over here. Now, obviously, as we know from general chemistry, this actually has a three-dimensional tetrahedral shape, which I'll draw for you guys right now. There we go, and we'll have one going out to the back. And if you haven't been aware of the wedge and dash structures yet, sometimes it's introduced, it should be introduced in general chemistry before entering organic, but the thick ones indicate coming out of the page. So coming out. And the dash lines indicate going in. And the ones that are just a straight line are aligned with the page, just so you understand that there is a three-dimensional tetrahedral structure, and obviously that the bond angle is 109.5 degrees between those. Just a little thing in case you should have that already. But anyways, it's a little review from general chemistry. So as you can see right here from the structure of methane, it has 4 hydrogens and 1 carbon, and that's all. It only has C's and H's, like I said, so it's a hydrocarbon. Then you see, is there any double or triple bonds? And obviously, since there is no second carbon to even consider, it obviously will be classified as an alkane because there is no double or triple bonds, only single bonds. Well, actually, you can't have a double bond between hydrogen and carbon anyway, so it just automatically classifies under the 1 carbon alkane of methane. Now, next one we're going to look at is ethane. Now, we're going to bump it up to have a second carbon so we can look a bit more at, the single bond structure that we're kind of looking for here. So now we're going to look at CH3CH3, which is ethane. I'll write that out for you guys as well. Now you're going to notice that all the hydrocarbons are going to end the same way, that have only one bond. It's going to end in ANE, ANE. And we'll look at some tricks on remembering all the prefixes like the meth, eth, pro, bute. And so you can memorize up to about 20 is what you're going to want to know. Most teachers won't ask you above 12, but 20 will be safe, just so you know. So what does ethane look like? It's CH3CH3. In bond line, it would simply be a line like this. But since we want to look a little bit more in depth, we will look at just a structure drawn out. So we'll have it right here. And we're going to have 3 hydrogens on each carbon. Right over there. And as you notice, between the 2 carbons in the middle, you have a single bond. And you're always going to be looking for the carbon-carbon bonds because that's the only ones that are going to be able to change. You can't have any other multiple bonds between the H and the C. So single bond, and it only has C's and H's, so it's a hydrocarbon, so it's an alkane. That's as simple as it gets. It doesn't ask for more. All you have to do is look between the bonds of the carbon and hydrogen, and then make sure that it actually just consists of carbon and the bonds between the carbon and the carbon, sorry, and make sure it only consists of carbon and hydrogen. So the next one we're going to look at, you can see it just follows a similar pattern. Now, what happens if we have 3 carbons? Now, you notice that you only can have 4 bonds on every carbon. So, I can't put CH3, CH3, CH3 because then something would have 5 bonds. So the middle carbon, when you have 3 of them, assuming that everything is in a chain right now, which is the only arrangement you can have. After you go higher than, once you get to 4, you can actually start having some isomers, which are different arrangements, which we will look at in a following video. I want to try to keep everything rather brief. You can see now we have, this one over here has 4 bonds. This one is attached to both carbons and 2 hydrogens, so that will make it 4 bonds. And this one here is attached to 1 other carbon and 3 hydrogens, giving it 4 bonds. So as a bond line formula, it would be this. And as a drawn out, just so we can look at the complete structure, we would have something along the lines of this. Just filling it up, and like always, we do a checklist. Does it only have carbons and hydrogens? Yes, it does. Does it have single bonds between the carbons? That's a single bond. That's a single bond, and it only has C's and H's, so yes, it is an alkane. Now, what is the prefix for it? When we're talking about 3 carbons, we're going to use the prefix prop, and since we're talking about a alkane, we're going to use the ending ane. So that's right there, we can add them together, a little plus sign there, and we get propane. And that is the basic theory involving hydrocarbons. You have your little checklist, you just check your 2 things, and then if they both check out, you know it's going to be an alkane. So check for C's and H's, then check for the bonding between the carbons, and if everything goes according to plan, you should have a alkane right there. And we're going to be identifying how to name these and how to memorize the names, because they could get a bit complicated, methane, ethane, propane, butane, pentane, hexane, heptane. It goes up a lot, and there is something for everything, so we will look at that in the next video. So if that's what you're looking for, I will have some tricks on memorizing that next video. Thank you very much for watching. My name is once again Casey, and with the Montreal Student Network. Thank you very much for watching, and have a great day.